In this example, in the circuit shown in the below figure, initially switch is kept open for long time. Okay, then at time t equal to 0, switch K is closed. Obtain expression for current in this circuit for t is greater than 0. Full stop. Find the value of current at time t equal to 0.25 seconds. Then what will be the current in this circuit in one time constant period, that is tau, at t equal to tau. Determine the instant of time at which the current in the circuit reaches to 1.2 amperes. So this is the given problem. So this is the given circuit. So what are the things in this example given? First we have to list out the given data. So find the value of current at time t equal to 0.25 seconds. So for this time, how much current is flowing through the circuit? We have to calculate. It is I of 0.25 t equal to 0.25 seconds. This one we have to calculate. Then what will be the current? Next we have to calculate once again current in this circuit in one time constant. One time constant means time constant period. Time constant period is indicated by tau. So when t equal to tau, t equal to tau means tau is L by R. T equal to L by R. For this time, how much current is flowing? That one we have to calculate. Next is asking for what? Determine the instant of time. We have to calculate the time here. Instant of time at which the current in this circuit reaches 1.2 amperes. When in the given circuit, when the current reaches 1.2 amperes, at that time, what will be the time? For the particular time, you have to calculate. So first two things, we have to calculate the current for the given times. Here vice versa, we have to calculate the time. So now observe the network here. 12 voltage up 12 volt applied voltage is there, resistor 8 ohm is there, and inductor 10 Henry is there. So current IT is flowing through the network. Now what happens? At time t equal to 0, switch K is closed. This point remember. At time t equal to 0, switch K is closed. This is switch. T equal to 0, switch is closed means there is a connection. Connection occurs. Connection occurs means short circuit. So 12 voltage, applied voltage is there, resistance 8, inductor 10 Henry. Now it is a closed path. Now at time t equal to 0 minus, it means what? Time t equal to 0 minus means, it means before switch, and nothing but switch K is open. If 0 minus means switch K is open. We know that, remember, recall the points. Switch K is open across series RL circuit. Initial current is given as I of 0 minus is equal to I of 0 plus, that is indicated as the initial current I naught is 0. That is already we discussed. So let us represent as a equation 1. Now after the switch is closed, switch K is closed, that is indicated by T is greater than or equal to 0 plus. If T equal to 0 plus, of course, switch is closed. What happens? Applying the KVL to the network, we get, apply the KVL, minus 8 into I of t, minus 8 into I of t, minus, so arrow mark of the current is pointing here, because of that is a minus, 10 into d by dt of I of t plus how much? 12 volt is equal to 0. Now rearrange and simplify. I'm going to take this part, whatever we discussed in the theoretical concept, same thing here. This part I'm taking towards RHS, left with what? 12. Hence, these two terms becomes plus 10 dit by dt plus 8 into it is equal to 12. Next step is what? Let us make the coefficient of this term 1. Because of that reason, in the previous case, resistance R is there. Because of that reason, we divide by R. Here also 10 is there. Let us divide the entire equation by 10. 10 by 10 it becomes 1. 8 by 10 it is 0.8. 12 by 10 it is 1.2. So let us represent equation 2. It is what? First order non-homogeneous differential equation. Equation 2. By observing the equation 2, we can say that equation 2 is nothing but it is the first order non-homogeneous differential equation. If it is so, this kind of equations we are going to solve by using this type. Differentiation of I dt plus pi is equal to q. Compare these two equations. Compare these two. It is also what? This is also first order non-homogeneous differential equation. Instead of it, here I written I, p nothing but 0.8, q nothing but 1.2. Comparing these two equations, we can write p is equal to 0.8, q equal to 1.2. If it is so, if you are getting first order non-homogeneous differential equation, these kind of equations we are going to solve. We are going to get the solution for these kind of equations by using the formulae I of t equal to e to the power minus p into t integration over the limits 0 to t q multiplied by e to the power pt dt plus k into e to the power minus pt. Very simple. In this formula, let us substitute the values. We have the value of p and q. Substitute. Hence, I of t equal to, what is p value? 0.8 e to the power minus 0.8 t integration 0 to t. What is q value? Q value is 1.2 e to the power p is 0.8 t dt plus k into e to the power minus p is what? 0.8 t. So next step is we have to simplify this one. Okay. Next, simplify I of t equal to 1.2. So what this indicates? Integration of I will do the calculation here. I of t is equal to e to the power minus 8t integration 0 to t 1.2 e to the power point t dt plus k e to the power minus 0.8 t. Okay, this one you have to simplify, correct? See here. This one you have to simplify. Now 1.2 is constant. I will take it outside. 1.2 is constant. I will take it outside. E to the power minus 0.80 as it is. Next, integration of what? Integration of this term e to the power 0.80. So integration of e to the power 0.80 is e to the power 0.80 divided by 0.8. Limits are what? 0t. So limits t and 0 plus k e to the power minus 0.8t as it is. Okay. Now next step, I of t equal to, so I of t equal to 1.5 into e to the power minus 0.8t. Wherever t is there, t, substitute t, e to the power 0.8t. You may ask how it is 1.5, because very simple, 0.8 is constant. Take it outside. So 1.2 divided by 0.8. So simplify, we'll get 1.5. So 1.5 multiplied by e to the power minus 0.8t. And for this, apply the limits. Upper limit is t. So upper limit is e to the power 0.8t. Lower limit is 0. Wherever t is there, substitute 0 minus e to the power 0.8 multiplied by 0, it is 0 plus k into e to the power minus 0.8 t as it is. Next simplification, 1.5 e to the power 0.8 t multiplied by e to the power plus 0.8 t. Here minus is there, here plus is there. So it becomes 0. Power terms are added. Remember, power terms are added. Minus 0.80 plus 0.80, it becomes 0. Hence, power term is 0. Then e to the power minus 0.80, e to the power 0 nothing but what? It is e to the power 0 is nothing but it is 1. 1 multiplied by this one, it becomes e to the power minus 0.80 plus k as it is. For the simplification, I of t equal to 1.5 as it is, e to the power 0, that is 1, minus e to the power minus 0.8t, then the remaining term as it is. Let us represent equation number 4. But in this equation number 4, we don't know the constant value k. So let us calculate the constant value k. Already we know how to calculate the constant value k. Simply substituting t equal to 0. We are calculating the constant value, simply substituting the t equal to 0. In the above equation, wherever t is there, substitute t equal to 0. Find the value of k at time t equal to 0. At time t equal to 0 means I of t is 0. So our equation means I of t equal to 0, we have to substitute. I of 0 is nothing but initial current, that is 0, already we know. That is equal to 1.5 inside the bracket 1 minus e to the power t equal to what? 0. E to the power 0 is 0. Next, plus k as it is, t equal to 0. It becomes, power term becomes 0. Next, 1 minus e to the power 0. E to the power 0 is what? 1. 1 minus 1, it becomes 0. So e to the power 0, that is 1. Hence k equal to what? K equal to 0. So substitute this value in the above equation. Then equation 4 becomes I of t is equal to 1.5 as it is, 1 minus e to the power minus 0.8t plus k equal to what? K equal to 0. 0 multiplied by anything, it becomes 0. This is the what? Current flowing through the given circuit. So now we calculated how much current is flowing through the given network. But this is not the result. The result is what? Is asking for what? Find the current flowing through the network at time t equal to 0.25 seconds. Hence, at time t equal to 0.25 seconds, the value of current flowing through the given network is given by nothing but wherever t is there, substitute 0.25 seconds. Hence, I of t equal to 1.5 as it is, 1 minus e to the power minus 0.8, t equal to what? 0.25 seconds. Substitute and do the simplification of this one. We will get 0.2719 amperes. Similarly, and second point is asking for what? Find the what? Current. Find the current at one time constant. One time constant period. Time constant period is indicated by tau equal to L by R. So first calculate the value of tau. Tau equal to what? L by R. L is given 10, R is given 8. So tau equal to 1.25 seconds. Hence, at t equal to tau, the current flowing through the one time constant t equal to tau, that is given by I of t equal to 1.5, 1 minus wherever t is there, substitute 1.25, then do the simplification. We will get I of t equal to 0.9481 amperes. It is what? It is the current flowing through the given circuit at one time constant. At one time constant. So this much we are getting. And last one, reverse case, that is current is given. I of t equal to 1.2 amperes is given. But for this current, what will be the time we have to calculate? That is indicated by, I am going to indicate, for this current, we are getting t equal to t1. So we have to calculate t1 value. Hence, I of t is given how much? So in this equation, t is indicated by t1. Hence, I of t is given, that is 1.2, is that is given equal to 1.5 as it is, 1 minus e to the power minus 0.8. I am going to represent as a t1. This t1 we have to calculate. Hence, further simplification, 1 by 2, 1.2 divided by 1.5, 1 minus e to the power 0.8 t1 is equal to 1.2 divided by 1.5, that is 0.8 we are getting. Next, hence I will take this e to the power minus 0.8 minus e to the power minus 0.8 t1 towards RHS. This term I will take it LHS. Hence it becomes e to the power minus 0.8 t1 equal to 1 minus 0.8, that is 0.2, and apply the log on both sides. We will get, and do the simplification, we will get t1 equal to 2.01 seconds. This means t1 equal to 2.01 seconds, the current reaches at time t1 equal to 2.01 seconds, the current reaches 1.2 amperes. This is about the given example. Likewise, we are going to solve